All right, hey everybody. I'm going to give us just a quick rundown of the information in learning modules 1 and 2, just making sure that we really take a moment to sit with it and hit it home because I know it's a lot of new information coming at us relatively quickly, which some we might be familiar with and some of which we might not be as familiar with as we have not taken a formal chemistry course before. So first wanted to start off with an introduction to the atom, making sure we understand the different parts of it. These you should remember, hopefully from your 7th and 8th grade years of science. But this atom, remember, is going to be made up of a very simple set of pieces, yet those pieces can do a lot of different things. So first, in the structure of our atom, we have these negative red dots here. Remember, these negative red dots are going to be our electrons, okay? These electrons hang out around the atom in a space known as orbitals, okay? Those electrons hang out in spaces called orbitals surrounding the nucleus. So they are not within the nucleus and they are negatively charged. Inside the nucleus here, we have two different types of particles. One known as the neutrons, that is our green pieces here. The neutrons, remember, are not charged, so they are neutral, but they do have a mass of 1. Also recall that electrons have a mass of 0. Our protons are the blue positive particles in the center, which, similar to neutrons, are going to have a mass of 1. Okay, so these are the three particles that make up our atoms, right? We've got 2 in the center that make up the mass of the atom, and we've got the electrons surrounding, which are going to be involved in the actual bonding of the atom to other atoms, okay? When we look at one specific element, okay, there's a way that we can tell which element we're looking at based on the information that we're given either in a diagram or that we know about that atom, okay? The easy way to tell what element you are dealing with is based on the number of protons, okay? The number of protons is directly going to tell you what element you are working with, because if that number of protons changes, then so does your element. In this element here, this atom that we've got 3 protons in the center. Since we have 3 protons, that corresponds to an atom of lithium because lithium's atomic number is 3. That atomic number is always going to match your number of protons. Now, what is also helpful is that that atomic number is also going to dictate your number of electrons if you are a neutral atom, okay? If you are a neutral atom. If you are not a neutral atom, then that number of electrons is going to change, and we'll get to that in a brief moment. Also on our periodic table, we've got just a couple of other pieces of information. We have the chemical symbol here in the center. That is the actual symbol that we use to represent that element. Underneath that, we have the mass of that of an atom of that element, and then below that we have the actual name of that element. Okay. Now, all of these particles are all intertwined with the information on the periodic table. Okay, like I said, the atomic number is going to tell you the number of electrons and the number of protons. Unless you are an ion, then your electrons are going to change. The other thing that we get to know from our periodic table is how the mass is involved, all right? So remember I said that neutrons and protons both have a mass, right? But when we look at this particle here, right, and when we look at this atom, we notice that there's a certain number of particles in the nucleus here, right? We've got 1, 2, 3 neutrons and 1, 2, 3 protons. Now those numbers can change, right? Like we said, if we change the number of protons, we change the atom completely. But if we change the number of neutrons, then we only change what isotope of that element we have. So in this case, with lithium, a normal atom of lithium is going to have an atomic mass of 7. You can see that here, 6.997, right? So that is going to be a normal atom of lithium with 3 protons and 4 neutrons, all right? As we can see, when we add those together, if we take our protons plus our neutrons, we get the atomic mass. So if we add those together, we get our mass of 7. Now, if we change that number of neutrons, if, for example, I added another neutron to make that a mass of 8, then we have created what we call an isotope, okay? An isotope is the same element with a different mass. Okay? It's as simple as that. The same element with a different mass because of the number of neutrons that we changed. All right? Now, we also briefly mentioned that the idea of ions, right? So if we change that number of electrons, okay? If we change that number of electrons, then that's going to change how balanced our atom is. Right now, you can see in this model, we have 1, 2, 3 negative particles and 1, 2, 3 positive particles. Since we have 3 of each, they cancel each other out to make this atom neutral. However, if we took that and added an extra negative particle on the outside ring of this atom, then we would have now an ion, okay? This ion would be known as an anion because it has 1 extra electron, or it is negatively charged. So anions are negatively charged because they have 1 or more extra electrons. On the flip side, if we took away that extra one that we talked about, and we then also take away another one, now we are left with 1, 2, 3 positive particles in the center and only 1, 2 negative particles surrounding, which means that -2, +3, add those together, we end up with +1. So that would be what we call a cation. Okay, a cation always has a positive charge. And I mentioned this in my video. Never forget it. Cations are positive. Okay, cations are positive. All right, never forget it. So these are ways that we can see changes in our neutrons and electrons that are actually going to change how our atom is made up, but both of these are still the same atom, element, lithium, okay? So even though we changed some things about it, we didn't change what element we were dealing with. The only way we change the element we're dealing with is if we actually change the number of protons. Okay, now that kind of takes care of the atom and looking at how it's set up and the different ways that it can present itself. Now I want to take these ideas and transfer them to the periodic table so we can see a little bit more about the periodic table and get a little more in detail with it.